You guys see my screen, right?
Yeah, it's able to use.
Okay. So let me start. Just give me a second. So what we are going to cover and what we are going to discuss, let me note it down here. So if it this going to be session for the Cisco ACI, okay? Cisco ACI, where we are going to cover the topics will be the ACI hardware overview. And in the hardware overview, we are going to discuss the Nexus 9K devices, what devices we are going to use, and why we need those specific devices to run the Cisco ACI. Then we are going to talk about the software-defined network, SDN. Then we are going to talk about the ACI overview. Okay, then after overview, we are going to talk about the basic of ACI, where we are going to discuss the logical configuration. Then we are going to talk about the physical configuration. We are going to talk about the L2. We are going to talk about the layer 3. Also, we are going to talk about the basic to advanced troubleshooting. And we are going to also talk about the layer 4 plus L7 with ACI. And we are also going to talk about the ACI with automation, how you can integrate the automation, how you can run the configuration through the automations in a simplest way. And we are going to talk about ACI with the virtual intro. In the virtual intro, we are going to talk about VMware. If you want me to cover some other hypervisor, I'm okay to cover as well. Okay. All right. So why we need ACI? Let's try to understand what is the ACI. ACI is not something which we can compare with any other devices. So ACI is not the alone ACI SDN network for data center. Okay, so let's understand the chronology of the SDN first. Software defined network. So how you do that configuration if without the ACI? Without ACI, how you do the configuration? In legacy network, we have three-tier architecture. What are the three-tier architecture we have? Three-tier architecture.
Excuse me, Vijay.
Yeah, Tarun.
Vijay, will the session be recorded, or we need to take our notes right now itself? Will we get the recordings?
Yep, you're gonna be recording.
Okay, we'll be getting that recording.
Yes.
Okay, thank you.
I'm recording that. So after class, in every session, you're gonna get the recording on the Google Drive.
Oh, thank you.
Yeah. Okay. So if we talk about the legacy network, suppose for example, you have the 100 devices in your data center or in your enterprise, right? In 100 devices, you have how you configure those devices, 100 devices. The legacy way or the old version way is to log into some jump host, right? And one more thing I forgot to tell you that I'm comfortable with English and Hindi. Okay, so if you're comfortable with any language, I'm okay to explain that. Okay, and if you have any doubt, if you want to ask anything, so feel free on that. Okay, so a legacy way is to configure that devices. Suppose you have 100 devices. You want to create the VLAN. Task is to create VLAN or SVI or routing. How you do that in a current scenario without the SDN, without the ACI? You have to log in to the jump host. From jump host, you try to SSH or telnet these devices, right? That's the very old way to do that configuration. That's very old way to control those devices, right? So to avoid this kind of time-consuming task and to resolve this kind of operational cost, industry came up with a one solution. They call that software-defined network. They say that, okay, I'm going to replace this jump host with the one controller, and that controller will be controlling all your hundreds of thousands of devices. Okay, so I would not say feature wise we are replacing the jump host to the SDN. However, I'm saying that here SDN, they have introduced SDN with the much more capability for SDN with a much more capability to replace the jump host. So it means we do not need jump host. Answer is no. You still need jump host, but jump host, the concept for the jump host was to control the entire infrastructure through it. If anything happened to jump host, you will not be able to do anything. You cannot directly land on the devices. That was the major drawback, as well as the jump host was just a transparent one box. The jump host has nothing to do with your any feature. It cannot configure any other device by itself. You just have to call all the devices from the jump host to get the login and configure that. However, in SDN controller, you are getting the control of each device, interface of each devices by default integrated to it. Okay. Does all the devices support the SDN feature? Answer is no. Not all the devices supports the SDN feature. If you talk about SDN, what type of SDN we have? There are a couple of types of SDN we have in the industry. So if we talk about different categories of the SDN, so if I go to the data center, DC SDN, because if we talk about the SDN part or the devices, we have the devices in enterprise where we have campus network, buildings, Wi-Fi integrated. We have the security devices. We have the service provider. We have the telecom. We have the different set of infrastructure available in the industry, right? You cannot just simply say that I'm introducing the SDN. You can just take that SDN box and integrate everywhere. No, that's not a possibility here, right? You have SDN solution for each domain. If you want to run the SDN part for the Catalyst switches, there is separate SDN solution for Catalyst. If you want to run the SDN solution for the WAN or ISR and ISR router, NCS router, there is separate SDN solution for that. If you want to do the SDN for the data center, you have different set of SDN for that. If you want to run the SDN for your wireless network, there is separate SDN solution. Okay, so there is various type of SDN solution available in the industry. So just use. Okay, if we talk about the data center SDN, in a data center SDN, there are a couple of vendor available in the market. Okay, so like we have Cisco, we have Juniper, we have HP, we have Arista, we have a lot of vendor which are available for the data center solution, which you configure those devices into the data centers, right? But for now, I'm going to talk about the Cisco specific SDN solution, which we call that ACI. Okay, when we call the ACI, ACI is not something a box which you can bring and configure that. ACI is the box for the specific hardware, which we call that Nexus 9000. If you have 7000 Nexus 5000 or Nexus 7000, you cannot run the SDN solution with those devices. Okay, so when we call that SDN, not all the devices has the SDN capability to support that. You need to have the special programmability feature. You need to have the special set of hardware to support the SDN solution. Okay, then we call that in enterprise. In enterprise, what usually you configure that? Wired and wireless, right? When you have the enterprise, enterprise means you have 2-3 offices where you want to integrate some, deploy the networks for the guest users, for your employees, for your all the corporate and non-corporate users to get the internet access, right? We call that SD access. In SD access plus we call that Meraki, Cisco Meraki solution. What all these solutions are? Meraki has different set of catalyst solution, as well as these are the catalyst. We call the catalyst 9000, as well as some of the different modules are available for the SD access solution and Meraki solutions. There is also some these are the mainly deployed. The purpose was to introduce the Cisco SDA solution, software defined access solution, to control your enterprise network. If you have suppose 10 offices in 10 different locations, right? How you going to control those offices? You control through you deploy one SDN solution. We call that SDA plus DNAG. You can also say that DNAG, and you control all the hundreds of thousands of the building devices through the one centralized interface. Okay. Then sorry, Prant. Any doubt? Anything?
No, Vijay, you can continue.
Then we come to the WAN solution. Suppose you have ISP, okay, and you have 5 to 10 locations, and you want to control those C router, customer is router, or provider is router for entire 10 branches or 20 branches, whatever you have. Because some customer, I work with where they have more than 300 branches, right? And to manage those 300 branches, ISP routers or the C router, customer is router is the most difficult job we have, right? Then we call that WAN solution, we call that SD-WAN, software defined WAN network, where we have Cisco solution, Webtila, and there are various SD-WAN solution are available, like VMware also provides that SD-WAN solution. HP also provide, Dell and Fortinet also provide, and Palo Alto also provide. Then we have, I think, Versa also provide. But I think out of more than 200, 300 SD-WAN solution, only top 5s are on the top 5 leadership position, including the VMware, Webtila, and Fortigate, Versa. These are some leader SD-WAN solution we have in the market. Then come to the Cisco. I would not specific to call that Cisco. Then come to the security. Okay, in the security, what SDN solution we have in the market? Because in the most difficult part is to manage the security devices through the automation, because you have to care about security. And if you have a banking environment or some some fintech environment, you will be focusing more on the security part than the counting the number of devices you can have in any your production environment. It can be any vendor, right? Here we call the centralized is for Cisco is FTD. We have 1000i. We have a SecureX. Then we have ICE. These all are the Cisco software defined devices integrated by default. So FTD, the reason I'm calling the FTD, because prior to FTD there was Cisco ACI, which was not controlled by any centralized interface. Okay, there was some ASDM, but that was not the I would say the SDN part. Okay, the SDN came into the security devices mainly on the firewall when Cisco came up with the FTD solution. Okay, where you can control thousands of Cisco ASA through the centralized interface. Okay, And there are a couple of other vendors available like Palo Alto, 14.8, Checkpoints, Juniper. There are a couple of vendors which are available for these kind of solutions. But let's focus on the data center. We are going to discuss in the particular module data center SDN solution. And in the SDN solution for the data center, Cisco is the leader for the ACI. Apart from Cisco, if you go to the Juniper, Arista, they do also have the SDN controller, but that SDN solution is not as good as Cisco SDN solutions. That's the reason 90% of the data center nowadays prefer to go with the Cisco ACI solutions. Now, if we talk about what Cisco ACI brings into the table, right? Is there any confusion so far here? Not? Okay. Let's talk about the Cisco ACI.
So basically, Vijay, wherever we heard the term Meraki, then we should automatically relate to the SDN in the wireless technology. And wherever we heard the term Viptela or something, it is related to the WAN network.
Exactly.
Right?
Yep.
Okay.
If someone is saying that we need SD access something, we just assume that this network going to be enterprise network. It means you have the 10 floor buildings or multiple offices where you are providing the wired and wireless access for your employees or guests or for all the users. So in enterprise network, we do not usually host that any applications, right? Applications we host inside the data center. Okay. So if we talk about the overall picture of this, all the three combined, okay, where we place all the devices, because in the data center itself, you're gonna get that all the devices, all the three devices. Okay, suppose you have, let me draw that. Suppose you have one application, right? This is the data center you have. Okay. In a DC, you will usually host all your critical applications. Okay, the purpose of introducing data center is to control or to host all the applications which you need for the customer base or for your user base. Okay, you have critical applications. Then on top of that, you introduce your security, right? That's second layer, SDN part. Security. Then on top of the security, what you introduce? You introduce WAN. WAN. Okay, this is one of set of the network which you have in the data center. This is overall we call that in the data center. This is how you deploy that. Then if you have multiple branches, you have multiple branch offices where your users try to access your critical applications which are hosted in data center, right? You will be controlling WAN router here. We call that ISP here. ISP here. Okay. And they connect like this. Okay. And these are the enterprise or campus network. Enterprise of campus. In the campus network, usually your users will be sitting right here. Employees. Yes. Suppose if someone want to access the guest Wi-Fi, right? Someone want to access the portal for anything, company portal or anything like that, right? So those all the users will be deploying as an SD access, and these users will be communicating with your data center for the internet access or for any kind of deployment. This is the overall picture of your SDN. So here we call that Viptila. Here we call that FTD, for example, Cisco solution. Here we call that ACI. Here we call that your Catalyst. Catalyst devices. Catalyst 9000, 3000, or 8000. Here we call that also ASR NCS, and ISI. Because some of the ISI also supports the enterprise solution as well as a border route. Okay, this is so in every hop there is a one SDN solution, because if you have the like 100 branches and all the 100 branches routers or the users try to access the one application which is hosted in the your data center. How they gonna get that? They will directly land on your local network. Then from local network you will land the data center using the WAN or ISP. Then from the data center you will filter that user through the security. Then through the security you will pass through the your data center devices. So data center devices are most scalable and it should be most scalable and flexible and agile devices and most high available devices you should have in the data center environment. That's the reason we focus too much on the data center side. In the enterprise network side, you can have any 1 gig or 10 gig of 100 gig or 40 gig device, but 90% of the time you will get here 1 gig to 10 gig interface, right? Here you will mostly get that 10 gig to 40 gig interfaces. Okay, here you're gonna get that 10 to 25 gig interfaces, but here you're gonna get here minimum 10 gig to 400 gig interfaces. Okay, because suppose if someone is reaching to your gas bank, for example, or geo retail, and they're trying to access the one of the website which is hosted in a data center, geo data center, or India's bank data center, they will directly land on the local office internet, and they can directly access through the here. So data center should have the capability to handle the millions of traffic per second. Okay, so here now industry came up with a solution we call that SDN, saying that in every hop we are going to introduce one controller for each solution. One controller for here, one controller for here, one controller for here, or one controller for here, where they are going to control. It means if you have one engineer or two engineers, they do not need to go to the data center for L2 connectivity or layer 3 connectivity or any kind of upgrade or any kind of configuration if in case happen. We are going to automate everything from single point of glass. It means single point of interface will be controlling your thousands of devices deployed in a data center, deployed in a WAN, deployed in a campus. Okay, I hope this gives you the better picture for the SDN.
Yeah, thanks. We got a broad detail.
Yeah. So let's talk about the Cisco Nexus product. Okay, in a Cisco Nexus product family, we have various type of Nexus devices available in the market. Okay, so let's go to here. Okay, here we have the first generation of the Nexus is we have Nexus. We had Nexus 1000, but no longer is available. Now we call that Nexus 2000 fixed devices. Okay, and 2000. We also call that fixed devices. These devices are brainless. Okay, it controlled via N5K and Nexus 7K and 9. Okay, you cannot configure those devices. You cannot deploy those devices standalone in your data center. Then we come to the Nexus 3000. Why 3000? And if someone want to purchase the 400 gig interface for the few servers, for if you have like 3-4 servers and you need like 40 gig interface, 100 gig interface, and you do not want to spend too much money in your data center, you don't have too much budget for that, you can deploy the Nexus 3000, where you're gonna get the 100 gig interface, 400 gig interface for your data center. Okay, so this is the best alternative solution for your the bigger deployment for the servers. Okay. Then we call that there are various type of Nexus 3K we have. Then we have Nexus 5000 and Nexus 5600. Okay, these devices we usually use for the core layer and distribution layers. We call that access layer. We call that access or distribution layer. This we usually focus on the distribution layer and core layer. Then we have Nexus 7000 and N77. Here we also call the Nexus 9000. No, this is the legacy one. So we call that here core layer. Usually we deploy this. So this is the legacy Nexus product you have. Now, the problem of this Nexus devices, these Nexus devices has some limitations. Okay. Next, when I call the limitation, so there is limitation. Let me talk about limitation. Limitation for automation, features. Then we have also called that scalability, deployment, time. Then we have operation. If you have 100 Nexus devices in your data center, or even we have 10 Nexus devices in your data center, how you manage that? You always have to do it manually, right? And scalability problem is these devices by default support the VXLAN. Oh, sorry, VLAN, which has so we call that we have VLAN and it can support VLAN range is 5094, for example. But does all the devices can clear the 5094 VLAN? Answer is no, right? If you have the hardware, specific hardware, Nexus 3K, Nexus 2K, Nexus 5K, those devices usually support that 256 spanning tree, STP and HSRP. Okay, so it means you do have the range for this much, but your device capability and is very limited. To overcome with this kind of issue and overcome with the feature issue, scalability issue, and deployment time issue, operation issue, and automation issue, Cisco came up with the one solution saying that, okay, I'm going to introduce one big mega device. We call that Nexus 9000. Okay, this Nexus 9000 initially Cisco introduced as a replacement for all the solutions. Replacement of all the solutions. Cisco said that I'm going to introduce Nexus 9000, which will be replacing your access layer, distribution layer, core layer as well. It means single device can work as all the layers. It means this can be your layer 2, this can be your layer 3. Now, the disadvantage of this Nexus 3000, Nexus 9000 initially was if you want to replace your Nexus 3000 or 2000, why you gonna get the Nexus 9000 which are much more expensive than these devices, right? Because if you want to get one Nexus 5000 device, those devices will be much more cheaper than Nexus 9000 because Nexus 9000 has more scalable hardware, it has more capability, it has more features based the ASICs available. So Cisco said that no problem. Usually all the Nexus devices run on the NXOS, Nexus OS. Okay, this is the operating system which all the Nexus devices use that. Now Cisco said that I'm going to introduce one more feature. We call that NXOS as well as the ACI, application centric infrastructure. It means with the same set of hardware, either you can use this hardware as an NXOS, it means as a legacy mode, as well as if you want to use this hardware as a ACI, you can use same hardware as ACI. It means you have one PC, for example. This is the example. You have one PC. In a single PC, how many OS operating system you can have? You can have two operating systems, Windows and Linux, right? But at a time, only one operating system can be active. Either can be Windows or either can be Linux. You cannot activate both the OS operating system at the same time. Same thing happens for the Nexus 9000. It means if you want to have the Nexus device, either you can activate the NXOS, either you can activate as the ACI. For what all the differences we have, ACI is the SDN solution where you're gonna get the one more extra device as a controller. Where you're gonna get this extra device as a controller for this device. Where if you want to still use these devices as NXOS, you will not be getting any SDN controller to control that. Okay, so there are a couple of Nexus 9000 devices available. Okay, so if you talk about the Nexus 9000 hardware, so first thing is not all the Nexus 9000 has ACI features. Okay, Nexus 9200, no ACI, it has NXOS. Okay, when we call that Nexus 9300, NXOS plus ACI feature. Okay, Nexus 9400, NXOS plus ACI feature. Okay, Nexus 9500, NXOS plus ACI feature. Then one more Cisco came up with a new device, Nexus 9800. 9800. NXOS plus ACI. Why so many different modules we have? Because if you want to replace these Nexus 2K devices or Nexus 3K devices, if you don't have the good amount for the or budget for the 9300, you can simply go and purchase the 9200 devices as well. That's the best replacement you have for the Nexus 9000 or the 1000, 2000 devices. But some of the devices are also getting end of life, end of support, like Nexus 9500, because ACI solution came in the market in 2013. Okay, Cisco introduced that. Since then, the hardwares are also getting end of life, end of supports. So that's why 9800 devices are replacement of the 9500 devices. Okay, same thing for the 9400 also, 9300 also. So let me open the data center switching where all the details you're gonna get here. Okay, so if you go to the Google, so let me just check. Yeah, if you type here next Cisco data center switching, Cisco data center switches in internet, you're gonna land on this page. If I open it, we'll see a lot of Nexus devices. Just yeah. If you see here these devices, we have 9300 series, we have 9400 series devices, we have 9500 series devices, then we have 400 gig 9800 series devices, and other devices will be there. Okay, if I open any of this device, for example, if I open 9300 devices, there are various type of models which are available. Okay, if I open that comparison module,
Good morning, Sandy. Good morning.
Please guys join with your actual name, change your host name, so it will be easy for me to capture that your details. So if you see here, look here, this is the 9200. It says that Cisco NXOS operating system, and this device has this much capability. Okay, if I open this table, 9200, look here, there's two types of model which are available. Look here, how many? So it depends on the module to module. If you read here, Nexus 90 to 32. So from the model number itself, you can say that this switch is 32 port switch. This is the 48 port switch. This it has meaning. If you see here about this name, so each switches has its name. Name is defined based on its model, based on its specifications. Okay. If you see the GC means this is the copper port, copper switch. This is the copper switch. This is not the SFP. This is not the fiber supported switch. Okay. If you see here how many interfaces you can have, look here. See that this 32 ports, it has 800 gig ports of total overall. 1 gig for each interfaces. Okay. And this is the power consumption, power type. This is the operating system which it can support. Now, same thing if I open for 9300.
Vijay, one thing. Just one. You said it is 800 gig, right? Maximum is 800, right? Maximum.
Is 800.
Below that we can use it, right? Na?
No, it's not the interface total capacity of it.
Okay.
It's not because it's I think it's 800 gig is not developed yet. So
Okay.
so
Thank you.
100 gig port is 2 here supported, 40 gig 2. So it's overall 800 gig ports. It means single port is 1 gig here.
Okay.
Either you can use or you can use a 25 gig interface or 40 gig interface based on what you need. Cisco will provide. Okay. The support, for example, if you want to run the VXLAN, can you go for this device or this device? You cannot go for this device. This device does not have the VXLAN support. Okay. So based on what you need, you have to go and check for the switches. If you want to run the VXLAN, you cannot go ahead and purchase any random device. For example, if you want to have 40 gig, 1 gig 40 ports or 1 gig 30 ports you want to have, right? In this case, you have to be very sure that what devices you want to purchase. If I open 400 gig ports switch, if you want to get that 1 gig or 10 gig interface based, it means RJ45 copper port, you have to purchase separate device. If you want to get 1 gig to 10 gig 25 gig ports, you have to purchase a different model number. If you want to purchase the 40 gig to 100 gig port, you have to purchase different model. Okay. And where all these devices we use that. So the major difference between the Nexus product between the Nexus Legacy to the Nexus ACI 9000 is the architecture. Okay. In Legacy architecture, we usually use that 3-layer architecture. Okay. If I open here, you have to understand the difference between Legacy Nexus and the current Nexus devices to correlate these devices. So here we have. Okay, this is the usually we use these devices. So if I go here, draw that.
Vijay, sorry, I just have one question.
Yeah.
Just for the better understanding of some of the members, can you just elaborate the difference between the Nexus and the Catalyst? When we go for a Nexus, and what difference we found compared to a Catalyst switches?
Perfect. So the major, so let me show. Just give me a second. Let me make one comparison. Okay, this is the Nexus. This is the Catalyst. And the Nexus devices, they support NXOS. Catalyst devices support iOS. Okay, Nexus devices can support the OTB, BPC, and Fabric Path. These are the some specific features which are only supported in a Nexus device. Okay, here we have VSS, no overlay technology. If you want to extend that layer 2 between the one data center to another data center, you cannot extend using the Catalyst devices. Okay, feature wise, this Catalyst devices are totally I would say that designed for the non-data center deployment. Okay. However, there are VSS feature. One, NXOS can work as an active. Okay. Here, no active. I'm talking about till legacy network. This is the legacy, okay? Legacy. This has more scalable. It has 1 gig to 100 gig ports. A 400 gig, I would say that. Whereas this has 100 MB to 25 gig easily. Then later they introduce 40 gig and other things. Okay. Here, this is the I would say that these are the, I would say that major differences are these, and itself you will see that there are a couple of basic differences will be there, which I think if I compare that, they're going to be like 30-40 differences, but these are some major differences which you can find there.
Because
Okay.
previously customer used to have a 6500 at least
Yes.
in their
Yeah, so the only difference I would say that for 6500 or VSS feature, it's not the 6500 feature, I would say the VSS feature. You cannot have the active control plane, right? If you purchase 2 boxes and you configure the VSS or anything, you just have the one box as active, one box as standby, right? Whereas in Nexus you have VPC. It means both the boxes will be acting as active. Okay.
Correct.
And I would say that here we have less STP, spanning tree. Here we have more spanning. Here we have RSTP and MSTP. Here we have PBST plus RSTP. Okay, so there are basic some differences which are available, which makes Nexus unique. I would say that there are only 3 to 4 features which can be unique, like PPC feature, OTP feature, active feature, scalability, better is TP. On some of the other protocol, like suppose if you want to do the MACsec, right? MACsec. This feature were not available in the catalyst. Now, after I think 9,000 catalysts, they are also giving the MACsec feature. But previously it was not available. Okay.
And the DAY-1 by default, Nexus all devices have that, or it is specific to few models?
It's a specific to the few models. So that's why when you purchase that, you go with the list of the features which you need. Suppose, for example, you need in your data center active device, right? You want to run the VXLAN, you want to run the MPBGP, you want to run the layer 2. Also, you want to run the PBR feature, policy-based routing feature. If you want to run the some automation. So these are the feature which will be you have to note down before purchasing any Nexus device. What exactly you need? Suppose for you need 100 or 10 gig ports. So what particular model number you gonna need that? So based on your requirement, based on your throughput, you will need that 1 terabyte throughput. Okay, throughput. In this case, you cannot purchase any random device. You have to be very specific how much throughput you need, how many interfaces you need, what features you need. Okay, based on that, Cisco sales team determine that, okay, this is the something feature you need. Okay, so I will be giving you this particular model. Okay. Now, if we talk about the legacy network, this is the. Is there any other question on this? Okay, and also major differences. It supports the SDN now. It supports the SDXs. It cannot be vice versa. You cannot deploy the Nexus devices in ACI solution. Well, Catalyst devices in ACI solution. You cannot deploy the Catalyst device in the so Nexus device with the SDN. So Cisco is keep maintaining the difference between the Catalyst and Nexus. So you cannot interuse that.
Yeah.
So this is the tier 1. This is the tier 2. This is the tier 3.
Is it possible to increase the font size a little bit? Actually, this I don't know. It's for me only, so you should be compact.
It's for everyone, guys, because I'm using that screen extension, so it should be bigger. It might be for you then only. Just try to switch to bigger screen.
All right, no problems.
Yeah. So here we usually use the core layer, distribution layer, access layer. Where we used to have the Nexus 2K, Nexus 3K devices. Okay, here we used to have Nexus 5K and Nexus 7K devices. Here we usually have the Nexus 7000. So sometime also it depends on the customer budget. 5000 also you can use that. And we used to keep the load balancer, and the firewall in this particular layer. Okay, that's a different way of designing. But most of the customer prefer to have load balancer to connect it to the distribution layer and the firewall connected to this layer. Some customers they also connect the internet directly to distribution. Some customers they also connect to the core layer. Now, usually we run this here as a layer 3. Here we run as a layer 2. Okay, and the problem is here. If you compare with the Cisco ACI, okay, this is a theater architecture you have, and how many devices you are trying to manage from here. If you have 2 devices, one here, distribution layer, core layer, and Nexus layer. So you used to have the layer 3 engineer for routing, layer 2, layer 3 engineer for the distribution layer, which maintain the layer 2, layer 3 configuration, all these. Then you have the server team here, right? Suppose if you connect to the VMware here, for example, VMware, we used to manage or the engage with the VMware team as well as the distribution or access layer or Nexus devices or data center engineer team to control that. Now, Cisco come up with the one architecture, so that I'm going to give you the leaf and spine architecture. Leaf and spine architecture. This is the also cost saving architecture. Is this particular architecture specific to the one device? Answer is no. This is the architecture. Leaf and spine architecture. What is the advantage of using this architecture? Sorry, not leaf. Leaf and spine architecture. The advantage of using architecture is here only 2-tier, easy to manage, easy to configure. The easy to configure means you're not trying to maintain the 3-layer device, right? You're saying that this is a spine switch, this is the leaf switch. It means all the layer 2. So all these 2 devices will be combined into a single device, and this device is replacement of this device. So you are merging your technology with your physical topology, and you are restricting layer 2, layer 3. And you are also getting the one hop feature. Suppose, for example, if there is one host connected, and these 2 hosts want to talk. First, how they used to talk? They used to go here and they used to come here, right? How many hop? 1 hop, 2 hop, 3 hop. Then it comes 4 hop, 5 hop, right? Now, if you have 2 hosts connected, how many hop it has? It go here, 1 hop, 2 hop. So instead of getting 6 hop or 5 hop traffic, you are getting everything in a 1 hop, 2 hop. So hop count is also reduced, as well as the maintenance for these devices. The maintenance for these devices is also reduced. So whereas if you have like 100 devices here, you can deploy 100 replacement with the 20 devices. So number of the operation cost, number of the capital cost also went down because of this architecture. And this architecture is pre-validated. It means if you want to introduce your load balancer or firewall, you cannot introduce here anywhere. Okay, this is a spine. leave. Here you can introduce your load balancer. So you are just simplifying your infrastructure. You are using load balancer here, firewall here, as well as your in-host is also directly connected. The servers are also connected. Like this. So if we go to this as a load balancer, this is the firewall. This is the server.
So basically the role of distribution layer has been transferred to the spine side or
Leaf
to
side.
the leaf side.
Leaf side.
Leaf side.
So here is spine purpose to only perform the routing. All the encapsulation, decapsulation will be happen here. Okay. And the second advantage of using this one is to support the VXLAN. VXLAN always work with the 2-tier architecture. It cannot work with the 3-tier architecture. Okay. So if you see here, we have broad layer 2 network right here. Without VPC, it will be spanning tree here. But after VPC, you are reducing the spanning tree feature. Here you are getting everything active. Whether it's an interface level, whether it's a hardware level, everything is active, as well as you are also performing the load balancing. So this is the one of the basic advantage with the NXOS. Okay, I'm talking about for now NXOS, not the ACI. If you want to run the feature with the 2-tier architecture, this is all about the NXOS. Okay, whether you can also interconnect. So the 2-tier architecture design is also suggests that like we have here interconnection, right? Here like this, interconnection. 2-tier architecture say that you do not need to connect this. If you do not want that, you do not need to connect that. Everything you can send through the spine switches. But if you want, you can do that. This is the one of the best, I would say, the pre-validated design which is available for the data center. From if you like to do the transformation of the legacy network, you should never replace the like-to-like infrastructure, right? So all the configuration now, Cisco said that since I already have the leaf and a spine architecture, let's take the advantage of this architecture. Rather than introducing different set of topology or anything like that, I am going to take advantage of this architecture and I will introduce one SDN controller and I will plug to any of the leaf switches. Now I will convert this NXOS with the ACI with the same architecture. I'm not changing any architecture in your data center. I'm simply just changing the style of the interface to support the SDN network, because this SDN controller will talk to these devices if these devices are running some sort of clients, right? And that client, I would say that is an ACI image. Like we have an NXOS image, here we have ACI image. We will have to install ACI on all the devices in order to integrate with the SDN controller. Okay. Now the style has to, yeah.
So you are saying basically leaf to leaf connection is not required, but it can be done.
It can be done for the NXOS I was talking about. Okay. It can be even for the ACI, you can do that, but that feature is not supported. You have to tune the special configuration between them, like for example, MCP, all these things, which I will come to later.
Because
but
the traffic from one leaf to another leaf it has to go through spine only in that case.
Yes, you are making the much more simpler. If you want to configure the anything, let's suppose if you want to configure the BPC, right? In legacy network, we have BPC with the directly connection, right? It has certain requirement. You need to have the 3 interface minimum, kind of. You need to have the port channel. You need to have you have to spend a lot of extra money to configure the BPC, right? You have to purchase the 10 gig ports. Right. Here you are saying that, you know what? I don't need anything to form the BPC. You just connect me to the spine switch. I will ask BPC configuration discovery from the spine switch itself, and I will talk through the spine switch. The role of spine is to forward the traffic, not to take any decision. Okay. So this we call that ACI. Okay. What all the devices we use for the leaf and spine? So let's come to here. What all the hardware we require? Here we have 9300. Not all the 9300. Okay. Only specific module of the 9300 support is a spine switches. 9500, 9800. Okay. If I go to the leaf switches only 9300 or 9400. You cannot deploy the. This is to talk about the leaf and spine architecture. Okay, so in a leaf spine architecture with the NXOS mode, leaf can be your 9200. Okay, plus 9300 plus 9500. Okay, and spine can be your 9300 plus 9500. But in ACI, when it comes to the ACI, what ACI hardware? Not all the devices support everything. Okay, in the leaf switches you can have the 9300 plus 9500. Sorry, 9300 plus 9400. In a spine switches, 9300. There is exception. Not all the devices. Then 9500 plus 9800. Okay. Now, if I go to the data sheet of these switches, if I open, for example, if I open 9300 series, if I open these series, there are a couple of models which are supporting 400 gig. If you say here, what is the role of this one? Saying that you can use this device as a leaf and spine for NXOS. As well as if you see here, this device is supporting ACI, leaf and spine both the role. It means you can use this device either as a leaf or either as a spine switches. Okay. Now, if I open the other model number, just move that right. These are the some feature. Okay. So these are some software feature. If you're purchasing these devices must be minimum. These are the operating systems. If I go to another device, if I go to this one, so any devices which has a 40 gig support to 100 gig support. Just to keep that easy, any devices which has 40 gig to 100 gig support will be supporting the spine switches. Any device which has 1 gig, 10 gig speed, that device will support the leaf. Just to be clear on that part. Okay. If I go here and check here, Nexus 93, 120, 108, 193, 48, these are the devices. If you see here, usage, only the leaf switches, top of the rack. It cannot be spine. Look here, the usage. For the ACI, okay, not for the NXOS. NXOS, you can use any device to anywhere. It's up to you. But for the ACI, this is the recommendation, saying that with the ACI image, you can use this model number as a leaf switches. You cannot use this model number as a spine switches.
Is there any, is only the speed capacity of the ports which defined to be used,
no.
make the switch can
so there are
there are
a couple of criteria for that. I discussed that. Okay, just I will discuss what all the features, what all the hardware uniqueness makes these specifications. Okay, but for now, try to understand these are the specific model number which support the leaf and spine switches. Can you? So question is, can you configure leaf and ACI with the other architecture? Answer is no. ACI is a pre-validated architecture with the leaf and spine. You cannot change the architecture. Cisco say that I have already pre-validated, pre-configured this architecture. You cannot mess with my architecture. Whatever I'm giving you, I'm just simplifying the role for you. Previously, how we used to design that, we used to design this network separately, we used this design separately, this design separately. Cisco said that you do not need to design my infrastructure. You just have to design your endpoint, how your endpoint need to be connected. Let me take care of the leaf and spine architecture and just deploy whatever I'm saying that. If I'm saying do not connect spine to spine, do not connect that. If I'm saying do not connect leaf to spine, leaf to leaf, do not connect that. Very differently, Cisco give the reason, but saying that if you are using the ACI, your architecture is pre-validated. You do not need to do anything. And I am going to take care of this leaf and spine configuration by default. Previously, what was the issue? We used to configure this one, right? These devices, protocol, everything we used to configure manually. Cisco said that you do not need to worry about anything. You just worry about the endpoint configuration. Endpoint configuration. Let me configure and control all the between leaf and spine configuration and design. This is the pre-configured, pre-designed, pre-configured, pre-validated. So let me show that. So in ACI, leaf and spine is pre-configured, pre-validated, I would say that pre-validated and I'll just keep it 2 point pre-configured, pre-validated. Okay, so you do not need to do anything between leaf and spine. Cisco said that I need this requirement. Say that I need this much interface and speed should be between leaf and spine this much, and let me control everything through the controller. The moment you enable the ACI image on this leaf and spine and connect these ports, those configuration and validation is already there. Design.
Is there any numbers which are fixed that how many leaves you can connect to a spine?
Yeah, there is a number based on your model number. Okay, so if you have the, I think it depends on your controller to controller also. Okay, I can do that. How many different spine scalability? I will cover the scalability section for ACI. I will cover that. Okay, so for example, if you are in a Nexus mode, suppose if you want to introduce one Nexus 3K device in your current environment, what do you have to do? Step by step. Anyone? In legacy network, if you want to bring a new device, first step is physical. That's basic. Then you have to do the layer 2 configuration, port configuration, then STP configuration, layer 3 configuration, then distribution layer change, then the core layer change. This much activity we usually get involved with. This is the legacy infrastructure. How you, if you want to introduce any new device, what is the ACI? After ACI, just physical connection. No layer 2, no port config, no STP, no layer 3 config. Yeah, layer 2 distribution port is not validated. Not applicable. So you're not doing anything. You're just bringing the new device here, saying that, okay, I'm going to bring new device, make sure you have the right image on that and plug this between them.
Not even
Or-
the management.
Sorry.
Not even the management IP configuration required.
No.
on the-
If you want to configure it, that's well and fine. You can do it from the controller. If you do not want to even configure the management of these leaf and spine, you do not need to configure it at all. If you have very tight budget in your data center, you do not have the budget to purchase new management switches and configure that. Even management activity can be done from the management access. Things can be done from the API itself.
Will there going to be some DHCP running to assign the IP?
Yes. So all the configuration, if you bring the new leaf switches in a production environment, all the configuration between leaf and spine will be automatically deployed, as well as whatever configuration, suppose VLAN 10 is available here, VLAN 20 is available here, 10 is available here. The same configuration will be automatically reflecting here once the you connect the physically and bring that from there. It means auto scale out is much more easier than your legacy infrastructure. Okay, if you bringing the new devices, you visit multiple times, right? First you visit for the rack and stack physical connectivity, then you do the software upgrade, configuration, you do the basic management configuration to provide the remote access to the engineer. These kind of things you have to do, right? Here you're not doing anything. You're saying that you do not want to provide the management. That's okay. Just make sure that I'm saying you that connect to that specific port and everything will be automatically done. We call that GTP, right? Zero touch provisioning. This is how powerful ACI is. Okay. No.
Only to patch up the links, we need to go and connect, touch the leaf switches. Otherwise, there is no requirement as such.
Exactly. So between the leaf and spine, definitely if you want to configure the in-house devices, that's a different case, right? I'm talking about pre-validated design, pre-configured design. Between leaf and spine, that's the main task, right? Configuring switch port mode access is a different thing. You have to do everywhere. But between the, if you want to integrate the new device in your existing infrastructure, that's the main case. You're gonna get.
Yeah, default architecture, we do need not to do any configuration.
Exactly. That's a pre-validated design and pre-configured design. You have to meet the physical requirement. The physical requirement, you should have the appropriate speed which Cisco required to connect that, and you need the ACI image if you want. You cannot run the Nexus and integrate that. Okay, the discovery won't be happen. So that's the basic two requirement. Physical requirement, make sure you meet that. An image must be uploaded any version. If you're running this 15.x version, if you're coming with 13.x, the Cisco says that no problem. You do not need to upgrade to same version. Just make sure that ACI image is installed in that. The from 13. To 15.x can be done remotely. No need to visit the physically to the data center.
Vijay, in simple terms, can we say that that legacy network is going to be replaced by the ACI by Cisco itself, that he wants to get upgraded, all the data center to be in ACI?
No, so the thing is, if you want to stick with the 3D architecture, okay, in this case, you have to replace these devices one by one. If you want to change your architecture, you are willing to do that. Cisco will say that use the Nexus 9000 with the ACI node. That's the best option available. Okay. But if you want to replace these devices, then replace with the 9300. That's Cisco usually recommend that.
So we can replace the legacy network into the ACI.
Yeah, definitely. That's why if you're deploying the ACI, 90% of the customer are doing the same thing. They are deploying the ACI and they are integrating their legacy infrastructure and they are migrating all the workload to ACI. Okay. The reason is there are a lot of advantages of getting the ACI. You do not have to worry about the loop. You do not have, because most of the, I see that because I work in a Reliance 5G deployment, and I work with even Airtel. I work with Yes Bank, all these things. Okay, so for all these companies, they were my customer. So I was part of their initial design of the this ACI. I was at Cisco. So this usually is much more easier solution. That's why Cisco suggested them to go with the SDN solution, because if you have a telco infrastructure, it may our banking infrastructure, you will definitely get more than 500 devices in your data center, right? And to manage 500 devices, suppose if you want to do the upgrade, okay, and your upgrade will be completed in 2 years, right? 500 devices. Doesn't matter what automation tool you use there. That service always will be associated with the legacy infrastructure, you know. But for if in the 2 years time period, if you are upgrading this device, in next year this device might be end of life, end of support. That was the major challenges in the data center. Okay.
So in a brief way, we can say that whatever the data centers which are running in legacy, there is a 90% chances that all the data center will be get migrated to ACI within
Exactly.
upcoming years.
Yeah. If anyone's not doing the migration, then as an engineer, we should convince them, right? Because that legacy design infrastructure is not adding any advantage to any customer. There are a lot of advanced features these devices supporting by default. By default, here we have VXLAN. 16 million L2 segment you are getting. By default, here how many segment you are getting based on your device scalability. It's not like you have 4,000 million will be supported. If your device line card is supporting 500 or 200 VLAN as spanning tree, that much only you can create that. Here we are saying that no spanning tree. We are going to run the VXLAN. We are replacing the spanning tree with the VXLAN. We are running all the traffic loop free, layer 2 over the layer 3.
But does the ACI make a valid use case only for the data center setup, or is it also going to help in the service provider access layer where we have a lot of access links connecting and stacking to
so the use case for this one is now Cisco realize that, because in order to support the service provider, you need to have the segment routing MPLS supporting, right?
Right.
But these devices, the ACI does not have these features. Now Cisco in a 6 dot or 5 dot, since 5.2 version, they are saying that segment routing we are going to support, right? But there are still bugs which are available in a Cisco ACI for segment routing, and that flexibility is not available, to be honest. I deployed for one customer and we had to roll back there. So it's always to base that Cisco, I'm not sure whether Cisco is doing intentionally, because if they introduce everything to ACI, what about the ASR and ISR router? So that's also use case Cisco think about twice before the design, design or introduce any product. If suppose if Cisco introduce firewall feature here, they are saying that firewall feature, security feature is available into the Nexus 9000, but firewall feature they are not introducing. The reason is, if they introduce firewall feature, who will purchase the FTD? Okay, so some features are intentionally left out from these devices. That's what I can say that. Okay. So now let's talk about the image, what images software we have. So I hope you understand the hardware point of view. Let me just give this here. If I open the 9500 series, so in the 9300, you have the 1 gig, 10 gig, 25 gig, 10 gig, 40 gig to 100 gig. Then you have the 9500 devices. If I open the 9500 devices, this 9500 device you can use as a core layer as well as if you are using the Nexus, like 9500, it has 3 model numbers: 9504, 9508, 9516, 9516. It means 4 line card, 8 line card, 16 line card. Okay, if I go to the number of the ACI, just give me a second, email file to upload. So the ACI supports, and it should also have the NX support as well. Okay, so these devices either you can use as an NX source or either you can use as a ACI. But make sure that you have to have the specific line card to support the ACI. Not all the line cards support the ACI. So in the Nexus devices, there are two types of categories. Okay, in Nexus product, there is two types of categories. Fixed and modular. Fixed means number of ports will be fixed. Okay, you cannot modify, you cannot remove or add anything here, right? It has flexibility to add or remove ports based on requirements. Okay, that's the difference here. Which one is more capable? The Nexus modular devices are more capable than fixed devices. Why we need fixed and modular two types of devices? What is the reason? So suppose, for example, if you open this, you have one access layer. In the access layer, we usually deploy that more than 5 to 10 devices, right? Based on your requirement. Now, the question comes up for the core layer and distribution layer. Can you deploy that multiple core layer and distribution layer and connect same access device to the other devices? Answer is no, right? That's not the best design you should have. Core and distribution. So Cisco said that suppose if you have 100 devices, 100 devices as access layer, and you need at least 1 terabyte of the throughput. And to come up with a solution saying that my fixed chassis is not going to have that kind of capacity, right? So I'm going to say that I'm going to bring one box, and inside the box, I am going to put that multiple 9300. As an example, I'm saying that I'm going to introduce multiple switches within the same box, and we call this as a, for example, 9500. It means multiple layer 3 devices will be introduced to here, and this device will be bundled together, and this we call that chassis or modular device. Okay, the second advantage we are getting here is how many control plane, how many CPU engines you get for the one device. Suppose this is a fixed chassis, 9300, right? In 9300, you get the simple one CPU, and the one CPU is controlling all the ports, right? Here, the modular say that I am going to make this device as a more redundant or HA, flexible. It means you can have the two CPU, you have the backup line cards multiple. It means if one fails, other should not be disrupted here.
So this spine switches also have same like catalyst, supervised sub cards, and then RSPs.
Yeah. So let me share that. Let me come with the architecture for the 9300, 9500. Okay, just let's come to that point where we say that, okay, this is the Nexus 9000 devices. Why Nexus 9000 devices have this feature, right? Why these devices does support the two features, ACI image as well as the Nexus image. What specific hardware we have. So when usually we would purchase the hardware, just give me a second. When you purchase the hardware, you get two types of if it is Nexus, okay. If it is NXOS, you get chip, we call that SoC. SOT, software on chip, something we call that. Okay. This is the ASIC, which NXOS support. Now, if you're purchasing the ACI, right? If you're purchasing the Nexus 9000 series, by default say that any switches, which is to say that if suppose a leaf or a spine or ACI image, so that okay, this device is going to be a little bit expensive. The reason is I am going to add one more chip on this device. We call that, previously it was ACI leaf engine and ACI spine engine. This is the two leaf type we usually get that previously. Now, since 9300 devices support spine and leaf both, Cisco said that I'm going to introduce leaf spine engine. It means single ASIC type. I'm going to introduce in the new second generation of the line card, second generation of the switches. Okay, this is the specific ASICs which supports the ACI image. For example, you have host here, right? This is the host 10. Host if you have server and which is running VLAN 10, for example. Okay, your traffic will be hitting on the SOC ASICs first, then it will go for the translation. It will go to the here, then this device will transfer your traffic to the this engine, leaf and spine engine. If this device is acting as a leaf, then this switch will do the encapsulation and decapsulation of the VXLAN. Then it will forward to the next hop. If it is a spine switch, it will not perform any encapsulation, decapsulation for your packet of VXLAN. Okay, this is the hardware with the specific ASICs makes this device as a unique 9000. Okay, if any device does not have this ASIC, that device will not support the ACI. Okay. Is there any question?
So I think this is the only difference between the NXOS and the ACI.
Yes. Because of this ASICs, VXLAN feature and the ACI features and the L2, L3 features are integrated with the ACI. Because what is doing here is, so ACI, NXOS devices already have the OSPF, BGP, all these supports, right?
Right.
But for the ACI, so for that, this all the feature I want to enable on the ACI image. So Cisco said that, okay, no problem. I'm going to use separate set of devices, separate set of ASICs we are going to develop, and we are going to interconnect this ACI ASICs with the NXWorks ASICs in a 9300. If anything going to happen, or if you want to run any image type, no problem. Based on that, ACI will self-adjust that.
All right.
Okay.
And just one more question. I don't know, maybe.
Yeah, please go ahead.
Like the basic, is there any difference in the architecture also on the OS level of ACI
Yes.
and NXOS?
Yes, there will be architecture differences. So I will be covering that always.
Okay.
Okay. So let's take guys like 10-minute break, then come back and let's discuss more on that. Is that okay to everyone?
Yes, Sujan.
Yes, yes.
We'll meet after 10 minutes then. Hey guys, everyone is back.
Yeah, we are there.
So let me bring one slide for the architectural design. Just a second. Yeah. So what we are going to talk about now, we are going to talk about the ASIC, okay, the hardware. Where architecture. In the hardware architecture, we are going to talk about the 9300 series. Then we are going to talk about the 9500 series. So before we talk about the hardware architecture, let me introduce one more feature. We call that in 9300 or 9500. There are various type of generation which are available. 93. Okay, when Cisco introduced the ACI, that was in the generation 1 hardware. Okay, generation 1 hardware had different type of ASICs. Generation 2 hardware had different type of ASICs. Now, generation 1 devices are end of life, end of support. So most of the devices you will be getting generation 2, generation 3, generation 4. How you going to identify these devices? So you have, if I just give me a second, let me open this. If you simply go to the Google and type here Cisco Nexus 9000 generation. Okay, so if I go to this one, I have tool to show that all the tool is already. Okay, so if you see here, if I say here, if you want to, run that hardware requirement, if I go to the, for example, this version, okay, so these are the some different type of switches we have available. So generation 1 switches is end of life, end of support. Now, if you see that EX and FX, right? There is simple FX, there is simple EX. These are the generation 2 hardware. If you see that any switches which are saying that 3, any hardware which is saying that 3 here, these are the generation 4 hardware. Any switches which is saying that 2 here, it means this is the generation 3 hardware. Okay, which one you should purchase? I would always say that always purchase FX3 now, because these devices has much more life than the other, FX and EX devices. These devices already are, some of the devices will be end of life, end of supports. Same thing for the spine switches. Same thing for the spine switches. So there are, if you see here, these are 9500 series switches which support the spine. These are the fixed 9300 which support as a spine switch feature. Okay, what these 3 generations have, what are the differences we have in 3 generations? Okay, let's talk about that. So the difference between these 3 generations are ASIC basis, hardware architecture basis. Okay, some, if you see that I have written here ALE, ASC, AL, leaf and spine engine, these are the engines, right? ASIC engine. If you see that some generation will have ALE2, ASC2, ALE, leaf and spine generation 2, 3, 4, this kind of generation will be updated in architecture. And what all the features they are adding? They are adding some small features. For example, MagSafe, CloudSafe, these are some extra features which they are integrating inside these ASICs. Okay, architectural wise, or 95% or 97% of the features going to be the same. Only one feature, two feature will be different. Some features will be supporting the fiber channel, some features will be, some switches will be supporting the SAN, some switches will be supporting only LAN. These are the features which are going to be available. Okay, so in the legacy, I forgot to say one thing. So in the legacy Nexus devices, what are the features we used to have? We have LAN and SAN, right? We used to get that LAN and SAN, storage network and the local area network. Same features are now merged to the Nexus 9300. LAN and SAN both the features. It means you can connect any storage devices, you can connect the SAN configuration, you can connect any NetApp or any set of storage, and you can run the fiber channel directly with the Nexus 9000. It's not like we are replacing these devices, we will not get any feature. We are going to get some extra feature as well on the Nexus 9000. Okay. So let me open this. If I go to here, I'll just.
So the older generation 3 and generation 2 are still coming to support the previous ongoing setups running already, right?
Yeah, so they are in the support, but Cisco, I think, already announced that we should be. So if I go to Cisco Nexus 9000 end of life, there's two things: end of life, end of support, end of supports. Okay.
Yeah.
So if you see here, these are some line cards. These are also saying that this is also now end of life for these line cards. So these are also end of life, end of supports, end of sale, end of life announcement. You know, if I open any of the Nexus 95 series, that's why I said the Nexus 9800 is now introduced, right? So if I open this supervisor Indian, this is that this can be used till 2025. But from Cisco side, this has been announced. Cisco give you that around 3 to 5 years of window to replace the hardware. Okay, you should be main concerned about when Cisco say that I am not going to support vulnerability and security. That's where you should be very much alert for your production environment. That's the main thing. Otherwise, Cisco announce anything to any time, right? So it's not a big deal. So this one is the main thing.
Because they stopped developing this
Exactly.
bug fix in
The moment they say that vulnerability is stopped, it means the based on the hardware or something, they will be stopped working on this hardware for development purpose. So you should be, considering those factors. Okay, let's talk about the ASICs. Okay, so in the Nexus devices, in old days, the ASIC we used to call that fire ASICs. Okay, there are multiple vendors which are available for the ASIC design. Then come to the Nexus. This is the Nexus old generation. This is the new generation with the 48 ports. Then this is the ACI. In ACI, we call that ASIC. What we call that? ACI is spine engine. Same thing we call that ACI leaf engine. If you see the 4 here written, right? It means this is the generation 3rd or 4th. If I go to the here. So in the Nexus normal devices, we have two types of SoC. Okay. Software on chip, we call that SoC. We call that an FE. And second is we call that VOQ. Virtual output queuing. These are the two types of ASICs which we usually get in the Nexus 5K, Nexus 7K, and Nexus 3K devices. Now, Cisco said that I'm going to get rid of VOQ because VOQ was third party. I'm going to stick with the SoC because this was the latest switch or ASICs which Cisco has for all the 9300 devices, 9400 devices, 9500 devices. Along with this, I'm going to also add the ASIC. Okay, this is the SoC is a Broadcom switch, ASIC, and the ASIC is a Cisco developed ASIC.
ASC also replaced by the SLE.
Oh yeah,
Spine
definitely.
engine,
So it's just a generation factor, as I said. So previously only a few devices. So if you see a matrix, right? So in early days, when we had generation 1 hardware, generation 2 hardware, 9300 devices, there are limited support which were available for this only. You cannot use these devices as a leaf switch. You cannot use these devices as a leaf switch before in generation 1. Now in generation 2 or 3, customers say that you are designing the hardware and forcing me to perform any, go for this design. But what if I have the extra hardware? I don't want to use this as a spine or leaf. Can I use this hardware as a spine? Can we use this hardware as a leaf? That something will save me cost, right? Cisco said that, okay, I'm going to introduce different generation of the leaf uh, ASICs or spine ASICs. It means common ASICs will be available on these switches, and it means they can work as a spine, they can work as a leaf switches. And also, I'm not going to design two different type of ASICs for my Nexus. I'm going to design just single ASICs, and that will be applicable for all the Nexus devices. So Cisco is also saving the cost. Also, we are getting the benefits as a customer. Okay. So if you talk about that here, so if you see here, this was the generation 1 hardware. In generation 1 hardware, what we used to call ASE and ALE. ACI spine engine, ACI leaf engine. Okay, in generation 2 switches which came in the environment, what we used to call this ASIC spine engine, ASIC spine engine, leaf spine engine. Okay, then these are the some ASIC type which we used to get at. For the 3000 and the 9000 switches. Now, most of the switches now get the LSE, leaf spine engine, which has multiple generation. If you see here, this generation is the first generation for LSE. This is the second generation. Okay. Now,
so is it like that? Is it like that? One switch will be having all three?
No, either can be this, either can be this. If there is AND, right? ASE means any device which is acting as Cisco is selling as a spine. That switch will have the spine is. Any switches which Cisco is selling as a leaf that has this engine. Okay. Same thing for the generation 2 also. In the generation 3, Cisco started changing the concept. Now, if you think about here, what all the advantage we were getting here. If you see the ASE engines, in ASE engines we were getting for the ACI spine engine. This was the capacity of this ASICs. Okay, engine 2 and engine 3, generation 2, generation 3. For all the leaf and spine standalone, what we were getting. So each generation has different type of skill here. Some ASIC devices support like 256, 128 kVRF, multiple span, multiple multicast routes. So enhancement has been made based on your requirement. Then it's come to the LSE, leaf and spine engine. Now, which is running in a generation switches. Just give me. So this was designed to support that all the standalone leaf and spine switches. Okay, and this was the for this one. It has MPLS label and all this LSR labels, fast thing, and this was total kind of same. I would say that they have replaced ASE with the leaf and spine engine, and they have made some sort of same adjustment for the different type of engine. Then they say that I'm going to tweak the LSE, which I'm going to focus, and the LSE will, I'm going to make some advanced innovation I'm going to add. What innovation they have added? They have added the hardware encryption, MACsec and CloudSec. These are the features they have introduced in generation 2. Okay, and they have also introduced the route policy tiles. Also, they have introduced the streaming hardware state, net flow format. Okay, and apart from that, there is also ASICs which are available from different vendors. So if you try to troubleshoot that or try to enable the ELAM capture, right? In ELAM capture, if you have generation 1 hardware, generation 2 hardware, you usually perform the different type of ELAM ASIC. If you have the generation 3 hardware, you tie the different type of ASIC. If you have generation 2 hardware, you will type a different type of ASIC here to in order to enable the ELAM capture in your hardware. Okay. So all the ASIC talk about these devices. Whether it's a 9500 devices, whether it's a 9300 devices, they all are going to support now this one. If you're having the FX model number, then it's going to be the LS generation from generation 2. If you're having the still this model number with the different fabric modules or something, then still some devices still support this model. Okay. Now, if you talk about the flow of these ASICs, okay. So if any traffic, suppose this is your box, this is your box. If any traffic hitting from your host, it will go to the input forwarding controller. Within the ASIC, this is the architecture of the ASIC. It will go to the layer 2 lookup, layer 3 lookup, ingress ACL, which we call the data plane, ingress forwarding classification, and here. This is we call the data plane classification. Data plane classification. It means if you are applying the access list, if you are applying the routing, if you are applying the layer 2 restriction, any policy, this will be always restrict to the data plane before pushing to the control plane. Then traffic will go to the QS. If you're having any kind of QS policy applied to your traffic, it will be always set the priority based on your QS policy. Then it will send to the control plane. Then from control plane, your traffic will be again revert back to the output data controller. We call that ingress. We call that egress. Okay, how the traffic is leaving, how traffic is coming to your device, and how traffic is leaving is two different directions, ingress and egress. Okay, now if we talk about the LSE has different sort of, now in generation 3, LSE has different sort of design now. If you see here, the packet arrived in the input series with the serial high speed input output keying. All this data will be and protocol will be checked based on your packets, whether it's a layer 2, layer 3, then it will forward for the next hop. If suppose you have applied the max security or port security or the access list, packet itself will be dropped on interface level. Packet will not go to the reach to the control plane. If you have any routing policy or the route map something, that will be always on the control plane. Okay. So
the MACsec security was not supported earlier.
Oh yeah, it was not supported earlier. So what is the limitation and the scalability? Let me show that some scalability stuff. Okay, these are the generation 1 hardware. Okay, first generation hardware. PX, PX, PQ, PX, TX. These are some generation 1 hardware. Okay, now this hardware you cannot find anywhere. Cisco is stopped selling this. If you have in your production environment these hardwares, always remove this hardware. Okay, and this hardware has a lot of bugs. So if you talk about how the SOC, which we call that NFE and ALE works. So this is how the integration works here. So first packet on the Nexus devices hit on the interface always go to the NFV or SOC. It will never reach to the first to the ALE. The reason is your ACI devices does the encapsulation. As I said earlier, packet will hit here, it will go to the SOC because most of the traffic you are encapsulating using the VLAN, right? Even now it's in ACI or Nexus devices does not have the native ACI support. It has just software which is supporting ACI, right? So once you receive your classical Ethernet packet from your servers, you will forward to your ASIC for encapsulation. So all the VXLAN related encapsulation, decapsulation, or configuration for the next hop will be always done from here. Okay, if classical Ethernet packet is hitting here, it will go to this one. So what it will say, I'm going to add the VXLAN header with the classical Ethernet. That something will be done via this ACI.
And what is the action done on the SOC side?
SOC will be always receiving the classical Ethernet packet, okay, from VLAN based packet. Then VLAN to VXLAN convergence will be happen on the ACI.
So it's just forwarding the all the packets by default to the ALE, or
no? So by default, it will for example, you configure the VLAN 10, right? By default, ACI convert your VLAN 10 to the some VXLAN ID. That's the default nature of the ACI. You cannot stop that. The moment you create anything related to the legacy, it will automatically convert hardware level to the VXLAN.
but
To
that
make
will
your
be done
packet
at that will be done at the ALE level, right?
Yes. That encapsulation, VXLAN based encapsulation, and the packet forwarding for next hop will be happen through the ALE.
Okay, and suppose if there is an L3 packet coming from the host,
same thing happen. It will go to the SOC, then it will go to the ACI. Because what happened is you have the layer 3 out. For example, you have the ISP, right? ISP has the one routing OSPF, for example. And OSPF is running between here to here. Then OSPF need to be distributed into the pre-validated configuration, which is ACI, right? That mutual redistribution, everything happened through this ASIC. Anything, any traffic which is passing or entering inside the ACI, it will be always hitting from this specific ASIC version. And when you try to troubleshoot hardware of the Nexus 9 kit, or you try to capture ELAM, right? You always type, either you can type this ELAM or you can capture this ELAM. Now, if you have different type of ASICs, ELAM will be totally different for you. Okay. So let me show you that how you're gonna get that. This is just the architecture. I will be showing that. Yeah, this is your ELAM capture. How you do that? If you're trying to troubleshoot if you're trying to enable the ELAM capture, you usually use the slice 0, slice 1. Why you use that? This is the ALE engine, okay? For example, ALE engine. Oh, sorry, LSE engine. When you try to troubleshoot your hardware or try to enable the capture in your Nexus devices, most of the layer 2, layer 3, you guys do the ELAM capture, right? And through the ELAM capture, how you troubleshoot that? How you identify which slice my interface fall under it? So there is a set of interfaces which will be part of different slice here. Slice 1, this is HS9, this is interface, this is the interface, all the details. If you want to troubleshoot the port between the 0 to 15, you have to find out which particular, this is my big engine. In the big engine, there is small pattern written into it, divided into 2 slices. Slice 0 for ingress, slice 1 for egress. Or it will also map the port out. So some port will be divided into here, some port will be divided into here, to make that your ASIC more scalable.
is it
Okay.
similar to a but we have quad 0, quad 1.
Yes.
XR.
Yep. If you see here, the internal TAH, the moment you say that show hardware internal TAH, you will get that what type of slices you have. Okay. Now, if you come to the, let me open generation 2 or the 9300 hardware, which is more important. Yeah. This is your internal architecture for the 9300 devices. Fixed devices. You have the LSE engine, and this is all the control plane, data plane design. This is the standalone, how a standalone devices work. Okay, you have the interfaces. Here you're going to have SOC. Then SOC will be integrated to the LSE. Then LSE will have the all the CPU integration for the all kind of health check or packet forwarding. Then it will have a lot of control platform, controller hubs, and all the line cards, USB, a lot of things are there. These are just control plane architecture. If you are installing your 9300 device, this is how your architecture will look like. This is the FX and EX version. Okay. If you talk about the difference and the features we have on the scalability point of view, what scalability we have for the LSE forwarding. So if we talk about this one, this is the generation 1 LSE forwarding capability. Okay, it can have like IPv4 routing, IPv6 routing, multicast routes. This much it has capability. Okay, so different ASICs and different generation of the ASIC has different type of I would say that supports or scalability. Okay, when you try to troubleshoot anything, you try to troubleshoot hop by hop. You try to troubleshoot ingress first, then try to troubleshoot egress. It means packet is coming from here and packet is doing all sort of lookup and you're trying to troubleshoot the egress. It means how the packet is leaving in your data from your device. Okay, so let me show that Cisco LSE engine. Let me show the scalability. Cisco ACI LSE engine scalability. If I talk about the LSE engine, usually we can find somewhere and find engine. You see that they are saying that with the LSE engine, this much is the capability. With the LSE2, this much is the capability. I can find somewhere Generation 3 also, because Generation 3 also has a lot of services and the scalability. Okay, and yeah, I think I can find. I will find later and show that different LSE type has different features. This is the fixed chassis. Okay, now if you come to the modular, this is a fixed chassis. If you come to the modular, how the modular works in your data center environment. Suppose you have 9500 series device. In the Nexus devices, do you know what modules we use? Anyone? a Nexus 7000, for example. Nexus 7000 modular. We use three types of module, right? Line card, we use the supervisor engine, we use the fabric module. These are the three main components which we use for the Nexus 7000. Now, if you come to the Nexus 9500 or 9800, we use line card, we use supervisor module, we use fabric module, we use controller, system controller. It means you have the line cards here. Okay. Your line cards will also have the two set of supervisor module, right? Then you have the fabric module. Then you have the fabric module. On beside that, there is a two small boxes will be sitting. Small boxes will be sitting. And they will be interconnected. So if you see here, let me show that. Just a second. Uh, 9500. Yeah. This 9500 has unique design than the hardware design than the legacy 90. Even if you compare it with the Catalyst or the Nexus, they were identical. Now the 9500 has said that I do not need to design the same way because I can get some different advantage as well for the using this type of design. Yeah. If you see here, this box has, this is the front end of the 9500. These are the line cards, right? These are the fabric modules. These are the supervisory. But if you see, two system controllers are sitting behind here, right? Without system controller, your box will be empty, and it won't be working, to be honest. Okay, there will be a lot of issues will be happening. What is the system controller represent here? If you remember the Cisco EOBC, do you know the EOBCs? EOBC. Cisco EOBC is the platform which has responsibility to provide the intermessaging between the nodes. Okay, so if we go to here, if I search EOBC, yeah, if you say here, no, so just if any two devices want to, suppose you have line card of control plane and data plane, right? You have one line card. In legacy environment, you have one line card and you have one data plane or control plane. This is the data plane. This is the control plane. So all the messaging between the control plane and data plane will be happen through the EOBC. It means, suppose if you have two engines running, if one engine fails, other engines become the active. Who is the one who is sending the notification to all the data plane, all the line cards? There is one protocol runs, we call the EOBC. Do we connect that physically? Answer is no. That something is dynamically designed by your Cisco. Same thing, EOBC replacement is a system card, system control, one, system controller, B or A. One become as an active, one become as a standby. Here we have line card, line card. Here we have supervisor engine. supervisor engine. Here we have fabric module. Now let's come to the generation, how they interconnect. These fabric modules, they interconnect like this. Okay, they connect like this. Then this supervisor module also connect to the fabric module. Okay, then this system controller also connect to the supervisor module like this. Now, if any traffic, why we need fabric module? Fabric module always enhance the performance of your packet forwarding. Suppose you have one traffic coming from one line card and going out from different line card, coming from here and trying to go from outside. Okay. In this case, if you're having a 100 Gbps speed, this can also increase your performance of the network, performance of the devices. Now, it has also one role. It also establishes the communication between the line card to line card as well as a line card to the control plane. Okay. Now, the EOBC role, previously EOBC role was to notify the message EOBC was configured here, and this used to send the message to all the devices. If in case of this as active, this is a standby, is running. If in case anything failure happen. Now after the EOBC removal, Cisco said that I'm going to introduce separate set of two boxes. The main role for these boxes will be to check the health between these boxes and notify to all the line cards and fabric modules. So based on that, they will be seeing this as active, this as a standby. If anything happened to this one, this control planes, or supervisor engines, or immediately notification will be generated to the system controller. The system controller will notify to all the line cards and fabric modules. Okay. Now,
Okay.
Is there any confusion on this?
No, not yet.
Okay, so the role for the system controller is to keep monitoring the health of the supervisor module. And based on the health monitoring, it will send a notification to the fabric module, then fabric module send to all the line cards. Okay. Previously, what used to happen is, previously supervisor module itself was sending the keep alive to all the line cards, right? And fabric module. Now, Cisco said that in this case, this supervisor module was sending keep alive in every seconds. And because of that, sometimes CPU utilization get higher. Cisco said that I'm going to introduce one separate device. The device purpose is to handle only all the out of band channel traffic. It means if any kind of keep alive messaging supervisor engine want to convey to all the line cards or all the modules, send to me. I will be the sender or the receiver for all the keep alive between the line cards and all the modules.
But how it's making a difference? Like only it is reducing some effort from the supervisor. Right?
Yeah, it's kind of reducing the role of the control plane directly interaction with the line cards for the keep alive. Because what happens is, if you're sending the keep alive every second, after 10 minutes, how many keep alive you're sending between line cards and supervisor modules? A lot, right? Along with that
Right.
EOBC traffic, you are also getting some data traffic also from line card for query, right? In this case, CPU utilization get higher. If you're having the STP, what's the disadvantage of STP? The BPDU, right?
BPDUs.
That's the reason we trying to eliminate the STP, spanning tree. Because BPDU usually send in every 2 seconds. And if you're having 200 VLANs, the switch will send 200 BPDU in every seconds. And packet size will be 8 bytes something, 4 byte, 8 byte. Same thing happened here. So Cisco said that, okay, you do not need to directly send keep alive to the any other devices, you just send to me directly. And this device will directly send that probe to all the line cards of fabric module saying that my supervisor module is healthy. Here we are saying that your job role going to be only to control receive the data traffic and transfer forward that based on your configuration. Do not worry about you keep alive sending to the other devices.
And where does the UBC come here?
UBC?
U
Supervisor. Where is UB?
No, but I'm just finishing out the term that recently you told me. What was that?
EOBC. EOBC.
EOBC. Yeah.
Full form is out of band. Sorry, Ethernet.
Ethernet out of the band channel.
Yeah, Ethernet out of band channel.
Yeah. How does that come here?
Okay,
Can you
so previously this engine itself has EOBC feature. A small engine was sitting inside. Okay, now Cisco says that I'm not going to create separate engine for EOBC for keep live message. I'm going to dedicate the two separate hardware module itself for better performance. Now, if I go and check that EOBC hardware failure, if any hardware failure happens in your environment, EOBC is the one who is taken responsibility for any kind of failure. This is a lot of bugs here. Like CPU one for failure detected, something like that. This is how your EOBC hardware works, right? But now EOBC, the role has been changed. Cisco EOBC architecture. Here. This is the better. Here. This was the EOBC previously. Deployed in line card as well as the supervisor module. And between them, they used to send the keep live. Okay, I should have somewhere EOBC my architecture. Just a second. This is the supervisor in band. Yeah, this is the traffic. I would say the EOBC traffic. Just let me find that EOBC. I should have that. Okay, so if you see that for the 9500, the system controller is acting as a EOBC for the intra and out control and communication.
Right.
Okay, this is the role of the system controller. After the from the management task, increasing system resilience, scalability. Okay, that's a major purpose of using that. There is also drawback for it because you are going to introduce extra set of devices, right, in the hardware. Okay, so this is how the architecture looks like for the. Now, if you talk about the multiple generations, so there is a line card called the 9700 line card, 9400 line card. These are the series of the line card which support in the 9500 modules. There is a multiple generation of the fabric module. Like we have to change the generation of the switches, right? Generation 1 to generation 4 we are running. Same thing, this fabric module generation, supervisor module generation, and line card generation has been changed. Okay, if I introduce the hardware details for the 9500, yes, look here. It says that these are the chassis 94 and 504, 9405, 8, and 16. And it has which line card. So if I say here, Yeah, these are the supervisor module generation. Say that this is SOUP 1, generation 1. The replacement of the SOUP 1 is 1 plus. SOUP 2 replacement is a SOUP 2 B plus. And these are the some specification of the supervisor. They have some extra RAMs and SSD and some, better performance. That's only way I can say that. Apart from that,
The line card numbering will also be in the same manner, right? As per the chases, right?
no.
Yeah,
So
it will be different.
it will be different. So here in the Nexus 7000, okay. If the device is configured 7009, okay. In this case, you have the 7 line cards, okay. 7 line cards and 2 supervisor modules. That will include the total 9 line cards, right? 7009. But in the Nexus 9500 series, yes, it says that 95004. It means 4 line card, 2 extra space for the supervisor module, 2 extra space for the system controller. Unlike the 7000. 7000 as if saying that 9. It means overall 9, total 9 boxes, including supervisor module. And the numbering was like you saying the slot number 1, 2, 3 was reserved for this, right? But in the Nexus 9500, there is no reserved slot for the line cards or supervisor module. The slot is separately being made for the line cards. They have said that I don't want to mess with anything. This is your supervisor module box. This is your line cards. Unlike the 7000, 7009 has some different slots. 7010 has some different. 7018 has some different slot for the supervisor module. Here is already pre-reserved in each boxes. Okay. Now, if you come to the supervisor module and if you come to the system controller, there is one system controller generation which is available. This is generation. Fan modules, these are the fan modules. Okay. These are just if you are using this particular chassis, you should having the fabric module, this one which I will be discussing here. So if you talk about this one, I got that one thing. Just give me a second. I should have. I should have the. But anyways, if you see here, lot of different modules you will be noticing. FM module, E, R, F. These are the fabric modules. These are the fabric modules. Here we have supervisor module A plus A, B plus, then B. Same thing. Here we have just single module, single version of it. Here we have multiple generations of this. If you're having 9504, the fabric module will be totally different. If you're having the 9508, the fabric module type will be totally different. Look here, fabric module. So that this particular E2 model number.
This ERS signifies. So what does it signify?
Yeah, let me show that. There is a something specification like this much. Just there is like the bandwidth and the utilization which will be behind what's here. So let me show that. The capacity and the engine also matter here. So if we go to this one, RX and R series. In the R series, these are the line cards which will be supported. Okay. So different fabric module has different line card supports. These are the line cards which will be supports. Okay, if you see here, R2 model supported to the fabric module 2, R2 and FM. So there is a matrix. Not all the fabric modules support all the line cards. Okay, look here. So it says that just give me a second. This is RX. RX means 36 ports. FM are fabric modules, saying that Cisco Nexus only. RS, this one is fine. Just give a second. There is a different meaning for each.
Each one there will be having.
Yeah.
No worries, no problem.
Yes. Like this one, if it says that FMG, okay, and it says that FME, it says that FMS, it has different supports. If it says the fabric module blank, this is the one. There is name, I think I saw somewhere. Yeah, just this is a name specification which you can use that for fabric module. These are the line cards fabric modules. If I say 95 as fabric module, if I say fabric module, yeah, so you can see here, these are the line cards fabric module supported. These are the line cards which will be this support fabric module. So we have 2-3 types of this is the line cards. Okay, this is fabric module FMR and FMR2 fabric module like this one. This fabric module, right? This one. Okay, FMR and FMR2. So I think this is the old document, but yeah, FMR and FMR2 has this line cards. If you have FMR, these line cards will be supporting. Okay, if you're having this fabric model, for example, FME2, let's see which line card they have support. Yeah. That's fine. If you see here. Okay, so also there is a for that I yeah, these are the line card FMC. These are the line cards which will be supporting the fabric module. This going to be support this much line card. Okay, so not all the line cards will be supporting all the fabric modules. So look here, this is the overall picture. If you see here, all the generation of the line cards, saying that FME, FME2, E2, right? So say that which line cards will be supporting which line, which series, and which mode. If you're having the ACI, you make sure that these line cards must be available. And which fabric module you have to also map that. Okay, what is the meaning of EX and FX? Let's talk about that, because this is related to the scalability. Okay, so just give me if I talk about the total capacity here, so FMG for the 9504 has this much capability as a fabric module, and this is the capability of each module. If you see here, if you're going with the FME, it will have this much capability. Maximum is throughput is flow is 100 gig, and this much power it will consume, all these things. If you are going with the this particular fabric module, this much throughput you are going to get, this much slot capability you are gonna get, and this is the width and total power and maximum and all the details you will find. Okay. Now come to the model specification. If you're having the EX, if you're having the FX, what will be the details? If you're having the FX, it means it will have the 100 gig interface. Okay. If you're having this FX line card and EX line card with the equal here, the meaning will be totally changed. Look here, say that FMG say that 1 point this much throughput you're gonna get from here. If you're having the E1, say that 800. So capacity wise, based on your requirement, you have to design. If you're having the E2 fabric module, if your fabric modules or your chassis has more than 800 gig throughput per slots, then suggestion is to go for this module, this fabric module. If you're having a less than 1 terabyte of the speed or something, go for this one. Okay, So name has itself, some specification. Let's say that E was having a 15 gigabit flow. E2 has now 100 gigabits. Okay, so each line card with the name itself, I tell you that scalability, because Cisco has defined their product based on the name itself. You can tell that which product has what capacity. Okay, if you talk about the line cards, there are various type of line cards. We have GX module, FX module, EX module. In GX module, we have 2 million routing, and this much is IPv6, and this is the scalability, MAC address, and all this thing. If you're having FX, you're gonna have this much MAC address, this much routing, all these things will be there. If you're having FX or EX line cards, generation 2, this is the generation differences. Like I was saying, with switches basis, in each generation of the switches, there are going to be the scalability differences. Okay. If you see that GX has the IGMP this much, they do not have the IGMP. If you talk about the other scalability point of view, look here, prefix support for IPv6. EX model has less prefix support. If you talk about the number of the IP entry or IP routes, how much it can learn. So again, this is totally you should be knowing if you are purchasing the device, if you're making the POM for the customer, and if you are already having this kind of hardware, from the name itself you can see that okay, if it is GX hardware, it should have the enough resources. And if you're having the FX hardware, so you can assume that this much is routing, all the scalability is there. Any other questions? And you should be knowing that if you are using the 9500 series switches, which line card you should be ordering. You cannot order any line card. Okay, you should be ordering the line card with the ACI mode support. Any question? I know this hardware is a bit boring. Yeah, this is how it is. You should be understanding the hardware before the going for the configuration or anything. Yeah. Any other question, guys, before we conclude today?
No, it's actually very informative, and it's build a good base before we proceed with the further things.
Yep. So configuration is not a big deal. Anyone can do the configuration, but knowing your product is a more important thing for the customer, right? Because if anything hard, because you guys are working mostly as a layer 2, layer 3, and layer 1 engineer, and you should be knowing that what hardware, what specification we have in the hardware, and how we gonna if you in troubleshooting happen, how you should be identifying and troubleshooting, and what level of troubleshooting you can do from this hardware. Because in every generation of the hardware, the troubleshooting and the command line is for the troubleshooting is totally different. So configuration is same, but troubleshooting, packet capture, all these things will be totally different. Some command will be different. Will be there. I will be showing you generation 2, generation 3 switches where you can easily identify. Okay, guys, then I will conclude here today, and we'll see you tomorrow with the another topic. I will go a little bit of more of software. Today we have hardware, and I will touch software, hardware both. Then we start the defense. I have covered the theoretical part for the today for the hardware. Tomorrow I might discuss the hardware with the lab logging. I will show all the details we have discussed so far. Okay.
Thank you.
Okay, guys. Then we'll see you tomorrow.
Thanks.
Thanks. I will be uploading that recording, and yeah. Thanks, everybody.
Thanks.
Yeah.
Thank you.
Thanks, Vijay.
Thanks.